This is 5.19D. So I had to do a little bit of work before I started the video so I wouldn't waste too much time here. I wanted to see what the biggest perfect cube that I could divide out of 81, and I found out it would be 27. Biggest perfect cube that could come out of 375 is 125, and then over here out of 99 is 9. Okay, so then I'm going to go ahead, and I actually like to write all my work down so I don't do too much in my head. And I always like to write the perfect cube first underneath my radicals just so I don't forget to do something with them. And root 11 is the lowest it can go. So the cube root of 27 kicks out a 3. So I'll just show my work over here so I don't have to make another step here. So it's a 2/3, kicks out a 3, which if you want to, you can write it as 3 over 1, which is 6 over 3, which reduces down to 2. This gives us 2 cube root. This is gone. This 3 has to stay there. This, oh, and I forgot to make that over 4 from up here. Cube root of 125 will kick out a 5, leaving the cube root 3 all over 4. This 9 is going to kick out a 3, bumps into that 4, becomes negative 12. This root 11 stays. This you can't do anything with it. So here, this is like saying there's a 1, it's over 1. We need to have common denominators if we're going to add our fractions. So we are going to multiply this by 4, and there's a 1 hiding here. I can do that here for you. So I'm going to times this by 4 and this by 4. So 2 times 4 becomes 8 cube root 3 over 4 plus 5 cube root 3 over 4. And then I'm just going to join those right now. Negative 12 root 11 plus 5 root 11 is negative 7 root 11. And here I have 8 cube root 3's plus 5 more cube root 3's becomes 13 cube root 3's all over 4 minus 7 root 11. And if you want to, you can make that over 1. There's no sense changing this to the same denominators because you see how your radicals are different. You wouldn't be able to add them anyway. So that will be your answer.